Hi, everybody. My name is Taylor Donich. I'm the Chief Technical Officer here at ProcessMaker, and I want to introduce you to a project our internal teams have been very excited about, and now I have the opportunity to show you. This is our ProcessMaker-powered automated QA platform. The intention of this project was to automate the execution of browser-based testing against not only our own product, but other web applications for our customers. And we've recognized that this is an opportunity where ProcessMaker can fit in any enterprise continuous integration and deployment pipeline and provide value, especially if you need to do any kind of post-deployment checks to make sure that the web server or web application is performing correctly. So let me just kind of walk you through why we chose to build this on top of ProcessMaker and kind of go through the steps of how it's executed. So ProcessMaker 4 is an enterprise workflow solution that is web-based. It is robust and extendable, so there's the opportunity to add extensions or plugins into this platform to change and improve its behavior. You can change the look and feel. Now, what we have here is a screenshot that shows the basic out-of-the-box user interface, but we have customers who are radically changing this interface to fit the needs and visual requirements of their organization. ProcessMaker 4 is extremely scalable, so we can handle tens of thousands of requests per second. And if we are doing massive testing at scale, we need a platform that can scale along with it. And what's great about this is a cloud-based infrastructure. So in AWS, we can actually test out web applications which are publicly accessible, or if you have applications which are internal through a VPN connectivity in order to test your application online. And then utilize parallelization. What that means is that if we have thousands of tests that need to be executed against an external web application, depending on the dependency tree of those tests, we can actually run those tests in parallel, maximizing the speed of your deployment. Remember how I said ProcessMaker 4 can be extended? One of the things that we did for this particular project was we made it so that we can actually execute Selenium-based browser testing inside ProcessMaker. So ProcessMaker has the ability to run what's called script tasks. These script tasks are segments of code that can be executed. This code can be designed and developed by our customers' development teams, our professional services teams. In this situation, we have a custom script task that is designed to run a single Selenium-based browser test. This is written in Python. Script tasks in ProcessMaker 4 have support for any programming language. So if you had Selenium bindings for the language of your choice, you could absolutely do that. For our out-of-the-box solution here, we are utilizing Python and Selenium bindings for Python. We also utilize Git for storing the test definitions, which I'll kind of show briefly. And what's the goal about each of these script tasks is each script task execution runs one particular test. So what happens behind the scenes is that anytime a test is ran, a very lightweight Docker instance is started with that test definition. The test is completed, and then the Docker container is removed immediately. And because this is a scalable layer, we can spawn thousands and thousands of Docker containers very, very quickly, run all your tests, and then terminate them all. And because we're running them in Docker containers, every test is sandboxed. So they're isolated and they perform independently from each other. As I mentioned, ProcessMaker is an enterprise workflow software, so this gives us the ability to visually design the automated QA pipeline and have it fit within any pipeline that you already have for your deployment. So what's great about this is that with ProcessMaker, you can fire off processes either through manual instantiation through a form or through API. So in our situation, we do have a deployment process that kicks off a actual deployment of the code base to target web servers, but then that then calls the ProcessMaker API to begin test execution. And I'm not going to go into the details of this visual map, but this allows an administrator of ProcessMaker to drag and drop steps into their CI/CD pipeline and to running tests here. This process map here allows us to parallelize all of the tests so that they can execute in parallel, and then build out a summary of results, sending those results through email as well as locally on the ProcessMaker instance. And then in our situation here, if the test is complete or even if it failed, sending the results of that test suite over to whatever is the next step in your deployment pipeline. For us, it is a AWS Lambda call, but it can change to whatever process or what is the next step in your deployment process. This is just a bigger kind of visual cue of there. This is our process modeler here. So all of these things are visually designed by an individual on our team. They're dragging over all of the tasks into the visual map, wiring it all up. But you can see that there are things such as pulling in the test suite, executing them in parallel, which is fantastic. And here is a screenshot of how we are manually instantiating a test suite. We are specifying the target endpoint. Now, what's great about this is because ProcessMaker is fully customizable, this startup screen can be customized to fit the requirements of your web application. So for example, here in this instance, we are testing a remote ProcessMaker instance. So we're kind of testing our own dog food. And in that situation, we're specifying username and password credentials. Now, one aspect of this test suite automation that is very unique to this is that the test suites are Selenium-based tests written in Python, but they're stored in a Git repository. Now, why do we do this? We do this so that we can have multiple collaborators who are writing test suites. We have the ability to branch the test suites so that specific test suites can be done on dev deployments, for example. And this also gives us history and logging of all the test suite evolution there. So there's a lot of advantages of storing the actual test suite definition in a Git repository. Now, of course, that means you can use GitHub, Bitbucket, or anything else Git compatible, and then just have the interaction of your test suites or the definition of your test suites in Git. So here you can actually see that we're specifying what repository is going to store our test suite, as well as what branch are we going to utilize. So in this process map, you're going to see something called the init loop, which both the manual, the form-based start, or the API-based start does. And what that does is it pulls down the test suite from the repository. That test suite has a master definition of what tests should be ran, and the dependencies of those, and then the actual tests themselves, which are just basically Python Selenium-based tests. And then what will happen in this process map is that it will go through each of those test definitions that it pulled down in the Git repository and run those tests in parallel. And then it will determine if any of those tests passed or failed. And then based off of the success or failure, send notification either through email of failure or actually call the success, which in our situation, like I mentioned, is AWS Lambda, but could be replaced by anything else. When the test suite runs, and this is an example of where a test suite potentially failed, we can have rich results that kind of determine what failed here. And because of how we've allowed the test to be written in Python and Selenium, we can customize the output here. So this is the same notification that's sent through email, or somebody can log in to take a look at the results directly in ProcessMaker. But we can see per test results and have custom success or failure messages for each test. And then also here is the activity log that we can see where the system is actually going through and running each of the tests in parallel. So that was a really brief overview, and we'd love to go ahead and demonstrate for you this in real time, perhaps even write test cases for your own custom web application. We're really excited about it. We're looking for feedback on this. What if this is of interest to you so that we can evolve this solution for your teams? But I'm excited that we're using this to test our own dog food. Hopefully we can use this to test your web applications, but we are absolutely excited and looking forward to your feedback. Thank you.